For this series in Spacecraft Guide, we are going to focus on how to fly modern spacecraft using the Space Shuttle as our training vehicle. We are going to concentrate on the primary flight instruments to teach you how the astronauts flew the shuttle in flight and in orbit. In this episode of Spacecraft Guide, we're going to continue to train you on how to fly the space shuttle, and we're going to use this actual mechanical display here that is in the primary flight instruments, which when you click here takes you to the primary flight display. And in the primary flight display, we are going to start a whole new part of the display, the tapes, which are these right here. We're going to start all the way over on this side with the Mach velocity scale, which that's Mach velocity here, and we're going to show you what those are. And when you click on that tape, it takes you to the Mach velocity scale tape page. Now, what the Mach velocity scale does is it displays one of the following: the Mach number, which is what the M is for, which is the relative velocity or inertial velocity. Mach number is the ratio of the vehicle airspeed to the speed of the sound in the same medium. And Mach here, the medium is air, which is why it's an airspeed. And then it's also the relative velocity in feet per second in relation to the launch site. Okay, so that's the relative velocity. So we have the velocity here, but as it's lifting off. It's also the inertial velocity in feet per second and does not consider the rotation speeds of the surface. And the reason why is when something is moving in a rotation that has a velocity, it actually has an acceleration. So this is just the inertial velocity of the spacecraft. The actual parameter displayed is always Mach number, and here is the big thing. The tape is simply rescaled above Mach 4 to read relative velocity for the major modes, and then we have here 102, 304, 305, 602, and 603. These are for takeoff and for coming back into landing, or inertial velocity, major mode 103 and 601. This is when we've kind of gotten out of the atmosphere, and so the Mach has to do with air. There's no air, so we're dealing with in space, and that's why we have to use inertial velocity. The range scale here is big. The limits are from 0 to 27. So this is the fastest vehicle around. It goes, well, usually it goes around Mach 25, which is hypersonic. This is a hypersonic aircraft, and which is basically above Mach 5, which everybody's talking about, the new hypersonic planes and missiles and everything. This was doing it back in the 1980s. And the max is 27. I have only heard that the max Mach here has gone to 26. There was one crew, they worked on the Hubble telescope, and they, because of the temperature, and they hit Mach 26, and they all brag about that, and they have their Mach 26 patch, which I think is not a NASA patch, it's their own. But also out here, you see we have the speeds. Well, if we look here, this is in thousands, and it's 5.32 thousand, and that is the vehicle speed, and that is in knots equivalent airspeed, so KEAS. So that is what this tape is all about for the Mach velocity scale. It's the first tape we're going to be using. And now for our Patreon subscribers, and it's also the free ones. And I gotta say, what are you waiting for? It's free. It doesn't cost you anything. And we're going to dive deeper into this tape. And when you click on schematic, it takes you to the schematics of the dedicated display and control system. And let's see, right over here we have our Mach indicator. That is in from the driver display, which comes from the computers, as you can see here. So this is our schematics that we have for the dedicated display and control systems. And you can see here that it is a section that has been broken out. And now for those of you who are paying subscribers, we're going to go even deeper into this tape, and we're going to go into why it is the not only the first hypersonic airplane that existed, going into the first reusable. Now, it before there was SpaceX, this spacecraft was being reused over and over again, and it also had engines that were able to be used again and to be throttled back and forth. And that was critical. And that this is what before SpaceX, this is the first spacecraft that was reusable that could come down and land. And although it was a part of it, the engines made it possible. So when you're a paying member and you click